of content, but I wanted to get at least one more video in tonight, so I wanted to jump back in. And the last session, if you watched it, we covered a lot. We created a new service, we built a routing slip with Courier, we set up an activity that communicated with that separate service that is representing our warehouse endpoint. And we really threw a lot of functionality out in that hour. So one of the things that I thought would be good to kind of look at in this episode was how can we monitor this? The call stack is gone. We're running in different services, different owners. How can we get a holistic view of our business and, go from that API endpoint all the way back to our backend services? I also want to take some time to add some capabilities to our inventory service, such as creating a saga to keep track of allocations so that if for some reason an order doesn't get processed or whatever, we can release that allocation and put it back into inventory. So we'll stop short of building an actual inventory management system and really just focus on how we can create a saga and use that with the scheduler to manage scheduling data. So when I get into that, I'll talk about the sample Quartz app, which I'm using to run the scheduler. It's a sample that's available on the GitHub site, but I'll cover that when I get in there. So that's what I'm hoping for. I don't know what our time frame will be to get all this done. It's a lot to cover, but I did take the liberties of making sure my application insights code worked because it's a little weird and I wasn't sure my account was still set up in Azure. So I'm going to start there and we'll kind of dig in. If you have any questions, definitely throw them up on the chat. If nobody's listening, then that's even better because I can just entertain myself, but whatever, I'm all good. I'm here to share the content and it's a good time for me. So let's get right into it. So Application Insights, it's an Azure service. There are a number of different details and blog posts on doing it. There's actually documentation in the MassTransit site that says how to set it up, which dependencies you need. So in this case, we're using the dependency collector. And the code that it takes to actually set this up is shown here. You can literally cut and paste this and put it in your application. That's exactly what I did for the two project services that we created. And you can see within the service code for program one, it is literally verbatim. The telemetry client setting up the configuration, all of that is right there. I did that for both services and restarted them. For ASP.NET, you actually have an additional setup. There's an ASP.NET Core extension for Application Insights that does the work for you. It's an extension that they put in there. Makes it very easy. The only thing we have to do then is tell it to add MassTransit's diagnostic source to that. MassTransit internally completely does all telemetry using the built-in diagnostic source library from Microsoft. So every time something happens, such as a message being sent, a consumer, a handler, a saga, anything, they all create activities using the diagnostic source. And those activities are chained together through a series of activity IDs that are passed as message headers in the message itself. So when I go out and create a message, let's say we want to create a GUID. We're going to copy this guy here. We'll go back to our website. We'll go back to our Swagger UI. We will, if you remember, we support several different verbs now. First, we support order creation, which with our particular customer, we're going to create that. We get a 202 that it was created. We can then go back, query the Saga to get its state. It's currently submitted. On the last episode, we added a patch because I'm trying to use every verb possible in HTTP. And that patch is going to trigger the order accepted event, which is then going to cause our service to go out and actually run the routing slip, execute the activities, allocate the inventory, which is then allocated in the warehouse service, and finish that up. Routing slip completes. And then we receive that event. We're writing that out in the other UI. Now, with Application Insights enabled on this service, I'm able to look at all that telemetry information and see what happened. So I'm going to click over to the Azure portal. We can see that there's some activity here. I was testing it. So if we show data for the last 30 minutes, it doesn't refresh that quickly. It seems to be like a 3 to 5 minute refresh time for App Insights before new reports show up. But that's okay, we can rock with that. It just so happens that I have earlier tests that we can look at that do exactly the same thing. So I'm going to look at the last hour. I'm going to apply this. Let's do a refresh. And we can see that I have some events in here already. I have an order state. I have events with this. I have check order. And these were at 6:45. So these were about 15 minutes ago. Let's look at one that we have here. Any of these we can see that we had a dependency mass transit courier context routing slip. Let's just click on one of these and see what happens. Wow, that's a lot. You can see the very initial action that was tied to this execution chain for this operation ID is the patch call to order/patch where I submitted the order ID and the request URL. So basically I accepted this order. From that event, I published, you can see mass transit called send. It did a send of the order accepted event. It sent it to this destination address, which is the RabbitMQ server's event name. It's a producer, because when you create spans, you're either a producer or a consumer. It has a source address, it has the activity, and it has the message ID. All those details in there. The command is the actual message type that was published. As soon as we published that event, the state machine received it, and it received it at this destination. That was the publish. This was the source address. The input address, because this is a consumer, was the order state queue. So I can see where that was received at. I can see that the repository went and actually loaded the Saga instance, executed the Saga raise event. The event that was raised was where's the event raised? Should be in here somewhere. Oh, the Saga type was order state. The event raised was order accepted. That's right there. It started in the begin state. It ended in the accepted state. And there's the Saga ID. So all of this trace information is there. It's all across different services. The patch was on our web API. The event was published from our web API. The event was consumed in a completely separate service, but that's reporting with the same telemetry key. At that point, we started the activity that called send. The send went to the fulfill order. As soon as we sent that message, we can see that the consumer over in the warehouse, or in the same service, this is the same service, got the fulfill order. Consumer received that message, started processing it, what the consumer type was, fulfill order consumer. It did a send to the routing slip to allocate the inventory, which immediately received that, called execute on the activity method. All of the different arguments are here, all the data is there, it's all in the telemetry data. It did a send of allocate inventory. That separate service did a receive. Warehouse contracts allocate inventory. The consumer was the warehouse components consumer. All of that flow all the way down to the response being received by the initial routing slip. So we can see that that whole transaction is wrapped within that. And I think if we go back down to here, we can roll that up. So after the allocate inventory, the routing slip activity completed event was sent. That routing slip event was received and processed by this routing slip event consumer. And the routing slip completed message was sent. It was received again on that same receive endpoint by that same consumer that's going to log that out. I think that's pretty cool. I mean, I have 3 different services. One's a web API, 2 of them are separate console services. They have a variety of consumers and messages passing between them. And I'm able to go up into App Insights and see an end-to-end flow of this entire transaction. Where the time took, you can see this whole thing from start to finish took maybe 1.2 seconds. And if you remember, we have a delay in there. We actually put a delay in one of the calls. I want to say it was like the allocate inventory call of like 500 milliseconds. So, it delayed before it actually reported its consume activity. So I think that's pretty awesome. I think being able to see this gives you an incredible amount of visibility. It doesn't take a lot of code. and it's all built in. There are other telemetry systems out there. I think Zipkin is one of them. If they work with Diagnostic Source and there's a way to hook them up, they should connect in. I haven't done that work because I don't have Zipkin. I just use this. But yeah, so that's good. I think if I refresh now, I'll probably see my recent one. Yeah, here's the one I did at 7:03. And you can see same output, same details. Here you can tell the service was up and running because we're at like the 500 millisecond time and my sleep is for 500 milliseconds. So all of the processing time is that await on the allocate inventory. But again, that full end-to-end visibility, all of the IDs, you can go query the database, see if they're there. Pretty cool stuff. Yeah, so that's App Insights. That's how you set that up. It's in the documentation. Pretty neat. So the next thing that I wanted to do in here is to introduce Quartz. So Quartz is a scheduling engine. It's a NuGet package that you can install. It uses a database to store scheduled inference. And within GitHub, there's the MassTransit sample Quartz repository. And I cloned this and just ran it. So there's a script to create the tables. I actually started up a SQL instance using the SQL Linux Docker container, connected into that Docker container, ran the initialization script to configure all the tables, and then was able to start that service. Now, I think it works. I haven't tried to schedule anything yet, but the scheduler started, which makes me think it connected to the database. So hopefully all is good there. We'll find out when we start coding that work in here. So that service is running over here. It's just been sitting there. It shows that it started the scheduler. I see the scheduler started message, so I'm hopeful that it's working. As long as it schedules, it's listening on the /Quartz queue. So I'm optimistic, fingers crossed. We'll see what happens. You can run a Quartz service anywhere. It just has to be running somewhere. Probably one of the common questions we get is, I scheduled a message and it never executed. The messages are just sitting in the Quartz queue. And that's because you actually have to run the scheduler service, and you can put it in with another one of your services. I just grabbed this one because it was already built and off the shelf, and you can run it anywhere. So now I actually have 4 services running. The only thing I didn't do is I didn't put the App Insights telemetry into the scheduler service. So I'll lose that telemetry when it goes through the scheduler, but that'll just be an external interactor and it'll start a new transaction flow. I could easily remedy that by going and putting the telemetry client into that. I'm not sure if it would actually pass the headers though. That's a good takeaway note. I'll have to look into that one. Okay, so I am going to enhance my warehouse service by creating a new component for it. So I'm going to go out and stop it first of all, just because I'm going to shut her down. I'm going to start working on it. And I am going to create a new saga in here, because what's going to happen is when I allocate an inventory, I want to create a saga that's going to keep track of that inventory. So I'm going to create a new directory called state machines. And while I'm here, I'm going to create another directory for consumers. And I'm going to move this consumer into the consumers directory. And I'm going to create my new state machine in here. So I am going to create the allocation state machine. And at the same time, I'm going to create the allocation state. So we're going to create that up. We'll just auto property the correlation ID, which is going to be the allocation ID. We are going to have a GUID. Oh, sorry, I got a public GUID. Scheduled expiration. We will need a current state. And we're probably not going to go too crazy on this one. If we're using Mongo, we'll have to do the BSON ID thing. So we'll get that in there. Now I'm going to install, go to my NuGet packages, and I'll just take the one from the other service. I'll add it to my warehouse service. I'll actually have to add it to my warehouse components. So then I have a decent ID. All right, so my allocation state machine is going to use MassTransit state machine, allocation state. I'm going to have a state of allocated. I will have an event of, and this is one I have to figure out, what are my current contracts? Allocate inventory. Inventory allocated is the response. That isn't my event. Allocation release requested. That's the one we send back. So I'll probably create a new event for this because I want to we'll call this inventory allocation created. What are we doing here? What was the other one? Oh, I had inventory allocated. That's not, I don't want to use that same one. Names. It's like one of the hardest things in programming. I'm just going to call this allocation created. This is an internal one, and I'm going to call this a GUID allocation ID. And I think I'm going to add a time span on here of hold duration. This is how long I want to hold the allocation for. So I created an allocation created. The event is now going to be allocation created. And I'm just going to call this allocated. Oh, I can't do that. I'll just call this inventory allocated or allocation created like I always do and just get over it. Now I'm going to come in and I'm going to generate this. I'm going to say I have my event. It is allocation created. It is correlated by ID. Again, the dot message dot allocation ID. And I'm going to say initially when allocation created, oops, then I want to initialize some values. I don't really know what it's going to be though. Don't really have to initialize any values. I have the allocation ID. That's all I really care about. I'm going to transition to allocated. Great. So I have an allocation state machine. It's initially allocated, but now I want to use that that time span that's in that message to schedule an expiration because I want to have this state machine get notified after the hold time to release the allocation. So I'm going to create a schedule, and the schedule has allocation state, and the message is going to be, and I have to create a contact for this, but I'm going to call it allocation hold duration expired. And so I'm going to create a new message contract called interface allocation hold duration expired. And that is going to have the GUID allocation ID. And that's really all I need. I don't have anything else that I really need there. Since I know this is going to go to me and I'm scheduling this to me, I'm going to show another feature of MassTransit that exists. So with this contract, No, I'm not, because then I would have to take a dependency. Never mind. I'm going to just use allocation ID for now. We'll keep the model dry. And this is going to be the hold expiration is the schedule. And I'm going to define that schedule the same way I do an event. Hold expiration. The allocation state that is, I need to specify a property for the scheduled expiration. So when a message is scheduled, it creates a GUID for it, obviously, because everything is GUIDs in MassTransit, it seems like. I need a place to hold that token. So I've scheduled that message. And the reason I want to do that is because if I want to cancel that scheduled message, I need that token so that I can cancel that scheduled item. So that's why that's there. The other thing I'm going to need to do is I'm going to actually have to create the message or I'm going to have to specify the scheduled settings. So the scheduled settings here, I can also just configure it. So I think I'm going to just configure it. One of the questions, it's kind of like an async task cancellation token. Yeah, it's kind of like that. It's basically saying I'm going to schedule this and I get a token back, and I need that token because I can't use a cancellation token or thread token. My process completely goes away between messages. So I can't maintain state because the state's out in a Saga repository somewhere. But yeah, it's exactly used like that. In fact, I think I will call it the hold duration cancellation token. Right on. Okay. Hey, welcome. God, I always forget your first name, but we'll just go with Maldworth. Maldworth is the one who actually wrote the Quartz service that I showed earlier for running Quartz. So mad props to him because it's pretty awesome. Saved me a lot of time because I was able to just install it. So the delay is something that we're going to specify. Let's just call the default delay equals time span from seconds. I don't know, from days, from hours. I don't know, whatever it is. We're not going to use it because we're going to use something else. Yeah, so I think that's all we have to do. I don't even know if I have to do that, so we'll let it go. So what happens now is when I receive this event for the allocation created, I want to schedule my expiration event, which I can create this just like any of the other dot methods that I have within the state machine. So I want to schedule, and I'm going to say hold expiration is the one I'm going to schedule. That's the first parameter that I'm going to pass to it. And then I am going to, which one of these am I going to do? I think I want to use the async message factory. I'm just trying to remember how to build it. This is where my brain gets a little foggy. Context dot init. What is it? Allocation hold duration expired. New context dot data dot allocation ID, comma, and I should be able to return a time span here. This is where my brain's really going to start frying. Yeah, schedule delay provider. So I'm going to say context dot data dot message dot, oh, sorry, the data is message, hold duration. Okay, that was a lot. So the schedule predicate, I tell it which schedule I'm allocating or I'm executing. I initialize the message that I want to send because I need to create that. And then in this case, I'm passing it a different duration, the duration specified in the message. And you might have missed it last night, but I had the beer last night, so it was all good. But I don't have the popcorn. I should totally have made some popcorn, but then me crunching would probably sound really bad. So that's my schedule. We're all good. I now need to be able to handle that message, though. So I'm going to say during allocated, when hold expiration dot received So essentially, so the schedule includes an event in it. It already defines the event, so I don't need to define the event twice. It's already there. So I can just pull that in. I'm checking for comments here. What? No, I'm not looking at Crohn's. No pictures from Drew during these recordings. Until it's getting late. It's like 7:30. Okay, so during allocated, when hold expiration.received, received is part of the schedule. So again, like I said, I don't have to create a separate event for it because it's already been put in there for me, and it handles all the correlation. In this case, when it expires, I want to, in this case, publish a command. I'm going to publish an event that will, release the allocation. I mean, somehow I need to tell it, that this item is never holded and basically put it back off on the shelf. I'm not going to do all of that because that's a lot more work. But essentially, I would notify the system, hey, that item that I allocated, I'm going to update my inventory to say that isn't held. It's now available to sell, or for a customer, it's available to purchase. And I'm going to transition to released. Released is a new state that I'm going to create. And I'm going to do that because I want to keep track of the allocation. I want to have a history of it. I could just finalize and tell myself to delete after that. That's totally an option I could do. In fact, I could do that as well. Yeah, let's do that. So I'm going to say hold expiration received, and let's just finalize. Because finalize will delete it and it'll no longer be there. You would probably never do that in a business because you'd want to keep track of it. But I'm going to do it just to kind of show how that works, because within the definition, I can say set completed when finalized, and that will tell the Saga repository to delete this instance when it's done. There was a question like 5 episodes ago, which was yesterday, around whether consumer sagas, the old style that have the initiated buys, can do any sort of finalizing to remove themselves based on message reception. And the answer to that is no. I added this when I built the state machine integration, and there isn't any checking in the dispatch filters for any of those message types that looks to see if the consume context is completed, is set, and deletes it from the repo. Now that is work I could do. I could add that, but it isn't there. But I could certainly add it because it's part of the system that's there. So the answer for that currently, though, is no. So if that's something that you need and want, put that, it's kind of like, mark complete. It's you call a method called set completed on the Saga consume context. And if I was behaving properly, I would actually delete that from the repo for consumer sagas. So yes, that was for you. I'm glad you're listening because you asked and I researched, and that's the answer. So great. So that's good. All right. So I have this created. It's going to delete. It's going to complete. It'll go away. I'm not going to publish an event at this point because I'm just going to expire, and I'll show that. Okay, so I think that's good. So I have an allocation state. I have that. I'm going to move it to here. With MongoDB, I think I also need the iVersion Saga from MongoDB. It's going to want that also, because that's one of the things that it's needing. And yep, that's MongoDB Saga. Okay. Now I'm going to go add this to my warehouse service, because again, this is part of my warehouse domain. So within the add MassTransit, I'm going to say add Saga. Oh no, I'm going to do my add state machine Saga. And what did I call it? The allocation state machine. Allocation state. And I'm going to use the MongoDB repository. I think I call that somewhere else. I'm going to use the same connection data. I'll just copy this from the other one, except I'm going to give it a different name. So this is going to be allocations. It should create it. And now I have the Saga. It'll configure that on the endpoint, and that should work. That's going to look at that event. I'm just mentally thinking if I've checked all the boxes here. The event is the allocation created. I need some kind of consumer here. Which one is it? Allocate inventory consumer. There's that delay. Sure enough, that's how long it takes to allocate. If I remove that, it would actually go really, really fast. So I'm going to do a respond async, but I also now have to publish the message, which is allocation created, context.message.allocation ID. And I'm going to say that this consumer probably has some sort of configuration, but I'm going to do a hold duration equals, let's just say 8,000 milliseconds. That'll be fun. Because that's a time span in the message contract, we'll get to see how it nicely allocates that and does that. So it automatically converts that to a time span based on milliseconds. So if it's seconds, I'm going to feel like a real dork, but I'm pretty sure it's milliseconds. Because we aren't waiting 8,000 seconds. That's going to be way too long. So the consumer is updated. And this is the only code I've changed. I haven't changed any of the code back within the other service. So I think if I just go start up the warehouse service at this point, we'll see if it comes up. So far, so good. Contracts, allocated, allocate inventory. Oh, hold on. Before we get too started, I forgot one thing. And I'm trying to remember how to do this. In our program for the warehouse service, so if we go back to our documentation that is, so useful, when we're using the message scheduler, we actually have to tell the bus to use the message scheduler. I hadn't done that, so I have to go do that. You can see in RabbitMQ that it's listening on the Quartz queue. I think that's which one I had. So I'm going to go configure that within my warehouse service that's now using a timer. I am going to, where do I create the bus? I am going to add the Quartz scheduler. Now I do that with RabbitMQ localhost. I could just as easily say exchange:/Quartz with the new shortened syntax, but we'll leave it because I'm pretty sure it works. Now I can go start the warehouse service, because if I hadn't done that when the Saga tried to schedule, it wouldn't have access to a message scheduler, so it would blow up. And we don't want an error on the first run. That would be no fun. So now we have those running. Let's go and generate a GUID so we can start an order from end to end again. I know most engineers would have probably automated this by now, but I'm not going to. So we're going to execute. Execute creates my order. We're going to go query the status to make sure that that piece worked. Status is submitted. We're then going to go call our patch, which is going to accept the order. I think if we go refresh our status again, we will see that it was accepted. If we go out here, we're going to see an error. Oh, see, I didn't configure something in the state machine after all. Oh, the instance state was not configured. Okay. So that failed. The error that we got was that the instance state was not configured. If we look at my allocation state machine and we compare it to the other one that I had created, you can see the missing statement right away. It's the instance state, which tells it which property of the state class to use to store current state in, was not specified. So I need to go back and put that in the allocation state machine. Once I've added that, we should be good to go. I'm trying to think if I forgot anything else. Hold on. Ah, yes. I'm trying to remember how this works, because I have to do something on here. Oh, I can't remember what it is, So I'm going to get an error because it isn't going to know how to correlate my received message to me. This is going to cause my brain to hurt. Yeah. Which one is it? Oh, this is going to mess with my head for a second. Because I think I need to configure state machine schedule configurator. Event correlation configurator received. And I have a set. Okay, yeah, so I have to set this. It's been a while since I've done this. S.received equals, we'll just use m dot correlate by ID. I'm running out of, so because the allocation ID property is there, I need to know how to correlate that back into the state machine. So that's why I have to specify the property. Just like I do up here for the allocation create correlate by ID, I have to do it here as well for the received event ID. Okay, glad I remembered that. That was one that was going to probably catch us on the third time running through it. So we'll start that up. Should come up. I'm actually surprised it didn't give me an error on that, but it probably wouldn't give me the error until it actually executed the message, and then realized it couldn't do it. So now I've got to create another grid, and I will go back to the executor. I will post my order. Order was there. If I go and get my state, I can see submitted. If I go to patch, I know somebody would have written a curl script for this by now. I'm just, I built this to make it easy. I can see that I did the patch. If I go refresh my get, I can see that it was accepted. And if I go out here and look, I can see that the allocation state received the message of the allocation created. And does anybody remember the time frame I put on the schedule? Because I'm wondering if the scheduler did its job. Failed to send message, the message. So it was scheduled and it failed to send it. Why? Invalid expiration. That doesn't sound good. Why would it expire? That's an odd one. So it received the message, created the model. So it received the schedule message. It got to the schedule message consumer. 8 seconds later, more than likely, I don't see the time on here. I need a better output filter for this. This whole debug info thing is a little wacky. Message was not confirmed, invalid expiration. Why would it be setting an expiration on the message? Man, that's a stumper right there. It tried to send it. I mean, but at least it's working. It actually did schedule the message, so I know that the database is right. What do we have in here? When in doubt, netcore project CS proj. When in doubt, let's see here. Aha. When in doubt, upgrade. How many more letters of this do we have? When in doubt, 6.2.3. Let's get the latest version and see if that fixes it. I really have no idea if it does or doesn't, but we will know shortly. So now I got to do this all again. because I can't just reuse the same GUID anymore. I'm getting pretty good at it though. So this time I'm going to skip all the intermediate steps. I'm just going to go to submit and patch. And then we're going to go here to the thing. It scheduled the message. It should have gone after 8 seconds. Hey, it actually sent it. So see, sometimes just upgrading is awesome. I have no idea why that would have failed in there, but whatever. We can see that the allocation state received the allocation hold duration expired message, which should have deleted that Saga instance. I don't know, is there a Mongo CLI that lets me look at, I don't even know what the key would be, so I guess it doesn't really matter. It worked great for Redis. But yeah, I guess since I didn't have to query this one, I could have put this one in Redis, and then we could have used the Redis CLI to get it. But nonetheless, we canceled that out. It received the message, and it was 8 seconds later. If we now go back to, because we've been doing this the whole time, let's go back to our search. Let's refresh for the last hour. Last one was at 7:36, 4 minutes ago. Let's see, oh, this was the check. When I did the check status, we can see where it was, went to the repository, called check, called send. That's just that smaller interaction there that looks like it took a whopping, I don't know, 25 milliseconds total. Let's come down here. This one has the state, so this is probably, oh, that's the get again. That's the check order. This one has an allocation created from the warehouse. Oh, wow, this is a lot bigger. Yeah, so now we've added the allocation state because the allocation created event gets published. We have the allocation state. It has the send to Quartz, and that's where we see it stop because, again, I didn't put Quartz into the telemetry client, so that data isn't in there. But yeah, otherwise, when the Quartz then sent the response back, it should include the message header of the activity ID so that it continues. In fact, it should have that anyway because it's in the message headers, but I don't know why it would or wouldn't. What does this receive? This is the .NET bus for which message? This is the allocate inventory allocated message. Okay. So that was the response client running in the other process, and we can see the process ID there. Okay, so let me look at my notes here because I want to see if I covered everything I was going to. Setting up application insights, showing the message flow, which is, yeah, I love that. That's so awesome. Added Quartz.net, showed the Quartz service, add the allocation expired event so that we allocated, and then we released the state from the warehouse. We didn't output anything here. I could do that just to kind of give us at least some sort of visual indication so that when this is received, we could do like a .then, or we could even do a .then async context console.out.writeLine async. So we can be async friendly. And we'll use our formatter to say allocation was released context dot instance dot correlation ID is going to be our allocation ID. So we can add that, and then we can do one more run of it just to verify and see that we get everything out there. Really, I'm just practicing my Swagger manipulation. Post order, patch order. We can see that we scheduled it, and we should see in about 6, 5, 4, 3, 2, 1. Boop. You can see the console allocation was released. That would have deleted the Saga instance. In fact, we can actually look right here and see that the allocation state instance was removed because that's logged by the logger output for the Saga repository. So yeah, that's all I wanted to cover in this installment. I'm actually surprised I got through it in less than an hour. We're only at like 45 minutes, so that's pretty cool. Appreciate y'all joining. I don't know that I'm going to do another one tonight. Let me look at my list of things I wanted to cover yet. I mean, if there's any requests, knock them out, and if I'm up for it, I'll put it out there. Otherwise, we might be done for the weekend. I don't know that I'll have any chance to create any more this week. It's going to be a pretty hectic week with a lot of people transitioning to work from home, so keeping the supply chain going is kind of important. But I think I got most of it here. I can't see anything else on my list, so I'm going to call that good for now. And pretty deep dive into a lot of different pieces of mass transit. Hopefully it's been fun. This and all the others will be up on YouTube. I'll send that link out probably tomorrow once everything's converted and I've verified the video quality. But thanks a lot, and more to come once I come up with some more ideas. So thanks for joining, and talk to you later.